So again, like I said yesterday, the written response, you're going to have two of them. They'll have anywhere between 3 and 4 parts per question, and they'll either be worth 5 marks each or 7 marks each. One of the two. That's a little better. Each of the parts, there's always going to be 1 or 2 easy parts, and then 1 or 2 harder parts. The harder parts typically are where they want an algebraic solution to something. So an algebraic solution of an exponential log, an algebraic solution of a rational, because those are the only 2 algebra units we have. So each of the parts, A, B, C, D, they're each going to come from a different unit. So you have one central theme for the question, but then each part comes from a different body of knowledge. Okay? So if we look at number 10 here, the price of a meal at a particular restaurant has been increasing at a constant annual rate modeled by the function below. So P is the price of the meal, X the time in years. Okay, I mentioned this yesterday. When you notice you have a variable in the power position, that means that this is an exponential equation. Okay, so it is important that you recognize what unit you're in because that will help solidify the knowledge that you have in your brain for that specific unit. Explain what the value 6.40 represents in this scenario. So if you go back to think about exponential, so if you think about exponential, the formula is y equals a times b to the x. A was our start, b was the rate. If it was bigger than 1, we called it growth. If it was between 0 and 1, we called it decay. So in this scenario, what does the 640 represent? It represents the starting price of the meal. It's the initial cost. So you can say it any way that you like, but that right there is 1 mark. So you need to get past your fear that written response means super hard. That's not it at all. The only thing with written response is that you're getting credit for your thoughts because you're going to get part marks. So if you don't quite make it all the way through, but you started off the question right, you're going to get 0.5 or 1.5 or 2.5, whatever it is. Okay, so here we go. Here's the algebra. So by the way, let's say it has 4 parts, A, B, C, D. A may not be the easiest, D may not be the hardest because they're all coming from 4 units. So because of that, if you really struggle, let's say on set theory, and part C is the set theory question, part C might be your hardest part, whereas A and B you might have found easier, right? So that's why you have to take it just part by part, right? Just keep swimming, just keep trying all the things. So it says algebraically determine the number of years it will take the meal to have a price of $15. Round your answer to the nearest year. So the price, so P is the price. So we've got 15 equals 6.40, 1.035 to the x. Okay, so solving an exponential algebraically always has the same 2 steps. We did 2 of these yesterday. We're doing another one today. Step number 1 is to divide both sides by the a value. So we're going to divide both sides by 6.40. So I would leave it just like this because it's probably a pretty nasty little decimal. I have no idea. Okay, second step, convert it to a log. So it's always the same 2 steps, always in that order. So when you convert to a log, you always start at the base and you say power of is. So the base is whatever has the exponent attached. So the base is whatever has the exponent attached. So your base is 1.035. So it's 1.035 to the power of x is 15 over 6.40. Now, you just have to mam your way through that. So 1.035, 15 over 6.4. So it says to the nearest year, so that would round to 25 years. Now, let's say for argument's sake, you accidentally rounded it to the nearest tenth of a year. They're going to take a half a mark off for that. Okay? So make sure, again, a highlighter can be your best friend on the diploma, especially if you struggle with rounding, highlight the words that contain the word rounding, and so that way you don't forget about them at the end of the question. Before I go on to part C, I want to go back to part A for just a second, because the other thing that they could ask you for is what is the percent annual increase. So that's the other thing that they could ask you. So instead of asking for the starting value of the meal, they could ask you for the percent increase. I've seen both questions as part A. Okay. If they ask you for that, what's the percent annual increase? That's from this part right here. So what you have to realize is that the percent is not 1% or 1.03%. That number, 1.035, represents 1 plus 0.035. You have to separate it up. This is the percent increase. So the price is going up by 3.5% per year. So that's the other very popular type of question they like to ask. Okay. I think because they did an algebra solving, they wanted to go easier on part A. This is a harder question. This is harder than this. Okay. So I think if they had just said, solve this and let you do it graphically, they probably would have asked for this, right? Because they have to balance the hard and the easy. Okay. Not every question is going to be stupid hard. Okay. So if you see it as a 1.0 or 1 point something, the 1 is not the percent. It's the number after the decimal. That's the percent. Okay, so part C. So we're still talking about this restaurant. So the menu consists of the following choices. 3 choices for entrees, 7 sides, 5 drinks, and 4 dessert choices. Jess must select, we talked about this yesterday. When you see the word select, you're going to think NCR because it's a combinations. Jess must select 1 entry, 2 sides, and 1 drink. She must select either 1 or 2 desserts. Okay. Determine the total number of different meal combinations that she can order. Okay, this one's kind of mean because you've got 1 entree and 2 different sides and 1 drink. And means times. So she's going to select 1 entree. So 3 choose 1 for the entree. And 7 choose 2 for the sides. And 5 choose 1 for the drink. Now she's also going to select a dessert. So and dessert. But dessert, she can select 1 or 2. So that means she can go 4 choose 1 or, which means plus 4, choose 2. So if you just interpret the question the way it's written, it's not too bad. But here's the catch. You have to plug it in with brackets around the plus, because you need it to do the adding. You need to find the total number of choices for the dessert before you can multiply it by all the other choices that you have. So you have to plug it in with those times, with those brackets there, so that, because if you don't, the calculator will do the multiply first. So what it will do, if you punch them out the brackets, the calculator will go this times this times this times this, and then add that onto the end. What you have to do is find the total number of ways of picking a dessert, and then multiply that number by all the other total ways of doing entree, side, and drink. So by putting the brackets there, you force the calculator to do that first. So I'll leave you to punch that into the calculator, okay? But that's essentially what you would do. Okay, so it's those brackets that made this question super nasty. We did a couple of them in class, not too many, but we did a couple. It's just, again, we did that in like February, like it's been a while, okay, a long while. Okay, so that one just had 3 parts. That was just a part A, B, and C. Okay, so that question was probably out of 5 marks. So 2 marks for this, 1 mark for this, and 2 marks for that. Okay. Okay, let's go to question number 9. Okay, so we're just going to go backwards, because again, these are the most recent questions. So like 9 and 10 were the ones off of January's exam, are very, very similar. Okay. Okay, so as soon as you start reading number 9, the odds against. Okay, so immediately you're into the odds and probability unit. So the odds against a successful putt are 17 to 29. So the odds against, so that means that you don't make the putt, you do make the putt, right? When it's odds against, the first number is the don't number. When it's odds in favor, the first number is the do number. Okay. Determine the probability. Okay, so probability, it is what you want to have happen over the total. So determine the probability that a golfer will be successful on his 5-foot putt. So you will be successful. So which number is being successful? The 29. So the 29 is that he is successful. The total is when you add those two numbers together, that is the total. So that would be 46. So you could leave the answer as 29 over 46. You could write it as a decimal, okay? Or you could convert it to a percent, whatever they ask for, okay? Usually they just want it as a fraction, okay? You should always check to make sure it doesn't go down, because they do like it simplified. In this case, it doesn't simplify down, so you can leave it as 29 over 46. But they will either tell you to express it as a percent or express it to the nearest hundredth of a decimal. Like they'll tell you how they want it. Okay. So again, 1 mark. Okay. Okay, part B. 24 golfers are surveyed at the clubhouse. The results are below. 3 golfers plan to eat both lunch and supper. 10 golfers plan on eating supper. 2 more golfers plan to eat lunch only than plan to eat supper only. Complete the Venn diagram. Okay, so this is now the set theory unit. Okay, so we've changed units again. So we've got L for lunch and S for supper. Our universal is 24 because that's how many golfers were surveyed. So again, when you're doing a Venn diagram, we always start in the overlap. The overlap is the and. So 3 golfers plan to eat both lunch and supper. So that is that number right there. Okay, this number right here, 10 golfers planning on eating supper, that is the total for the entire circle. But we already have the number 3 there. So if 10 is the total for the whole circle, that must mean then that 7 is there. Okay. 2 more golfers plan to eat lunch only than plan to eat supper only. So how many are eating supper only? 7. So how many are going to eat lunch only? 9. Now if we add them up, 9 plus 3 plus 7, that's 19. My universal is 24. So that means that 5 didn't eat lunch or supper at all. Finally, the question is, state the number of golfers in region L. So that would be the number of golfers in this circle. So that is 12. So set theory. Okay, so we've had an odds and probability question for part A. We've had a Venn diagram for part B. Okay, so we got 2 units down. What's our next unit? So notice we're still on the topic of golf, right? So that's the central theme. It's just coming from different units. So the probability that a golfer has a good first shot, also it's back to probability, okay? So the probability that a golfer has a good first shot is 0.72. If he has a good first shot, then the probability he'll have a good second shot is 0.85. If he doesn't have a good first shot, then the probability that he will have a good second shot is 0.53 because he'll get psyched out. Determine the probability that the golfer will have a good second shot. Okay, there's 2 conditions here. What's the first possibility? He'll have a good first and a good second. Or, what's the second possibility? He'll have a bad first, but still a good second. Because we want to know chances of having a good second. So this concept, we did it almost right at the very end of the unit. They're tricky questions, like they're hard. I have a feeling this would be the excellence level question for the probability because you do have to think about both cases. So or we know means add and means times. So let's fill in the numbers that we do know. What's the probability that he has a good first shot? 0.72. What's the probability that he has a good second shot given that he had a good first shot? 0.85. Okay, so here's the leap of faith you need to make. I'll talk about it as percents. If he's got a 72% shot of having a good first, what's the probability of having a bad first? 28. Because they have to add up to 1. Right? You're either going to have a good first or a bad first. Right? You're not going to kind of have a wishy-washy first. It's either great or not so great. So if he has a bad first, the second one being good is 0.53. So this question was hard for 2 levels. Level 1, it was hard because you had to think about both cases. Level 2 hard was that you had to make this connection right here. So all you would now do then is just plug that into your calculator and get out the decimal. So let's say on your work, you did 0.72 times 0.85 plus 0.72 times 0.53. Let's say that was the mistake you made. You're still getting 1 out of 2. Okay. Let's say you only did this and you didn't do that, then you're getting probably 1 out of 2 or 0.5 out of 2, right? They're trying, the only way for them to give you 0 is if you write down something so fundamentally wrong that they can't have anything redeemable in it, which I don't think you would do, or you'd leave it blank. If you leave it blank, you are forcing them to give you 0. So please don't leave anything blank because you're literally making them give you a mark of 0. They actually want to give you the marks. Okay. Questions on that? Okay. So this question had a part D. So usually on the diploma, one of them will usually have 3 parts. I've seen both questions with 3 parts or one with 3 parts, one with 4 parts. I've never seen both with 4 parts. If they do that, they'll make the 4 parts easier. Like they'll make them smaller, more manageable questions because they don't want you sitting there for hours. Okay, the distance from when a golfer, so again, sticking with the same theme of golf, the distance from when a golfer is teeing off to the front of the green is 150 yards. The distance to the back of the green from the tee box is 175 yards. Now, excuse my terrible picture. They do have graphic artists, and it was a beautiful picture on the diploma, and it was much clearer than that, but hopefully you get the gist of that. The path of the golf ball is given by the equation, where y is the height of the ball in yards and x is the horizontal distance traveled. So think about it like this. If we have got this golf ball, this is the path. This is the vertical height. This is the horizontal distance, which means you are graphing this thing in quadrant 1. Guys, 99% of the time, if they give you the y equals, you're going to plug it into your calculator. Okay? If the ball travels directly towards the green, so it's not doglegging or anything like that, it's going directly to the green, will it land in the front of the green, on the green, or behind the green? Justify your answer. Okay, so we haven't actually talked about this yet. Justify is a fancy way of saying, please show your work. So if you just wrote on your page, it will land behind the green, and you don't show any work, you get 0 credit. You get a mark of 0. Like the mark is coming from the justify. It's not coming from the answer. So if you don't show your work, then that's a problem. Okay? So, okay. So I'm going to plug this into Y1. Come on. Oh, come on. Okay, why is this? Oh, what's it going on here? Okay. Oh boy, there we go. Okay, I'm just going to stick with that. Okay, so negative 0.003 x squared. Now I've forgotten 0.522x. Okay. Now, I know I want to be in quadrant 1. So here's the thing. I know it's going to be 0 and 0. On the picture, I can see that this is 150 and this is 175. So I'm going to make my x max, whoops, I'm going to make my x max 175. Because if the ball doesn't hit by the time my screen ends, I know it's going to go off the back end of the green. Okay. Now, I don't play a lot of golf. I'm going to go 100 high. I have no idea how high it actually goes, but I'm just going to guess that. So if I go graph, oh, there we go. So this was 175. So I want to know what that number is right there. So in other words, I'm going to find the x-intercept. So second trace, x-intercept is number 2. So you can either scroll to the left and scroll to the right, or you can plunk a number in on the left side and a number in on the right side. So a number for the left, I'll go with 100. A number on the right, I'll go with 175. Hit enter to get past guess, and it lands at 174. So what the justify needs to be, you need to draw your picture. And you need to show that it has an x-intercept of 174. Because it hits at 174 and the distance to the back of the green is 175, then it's going to land on the green. So the justify is finding the x-intercept. Okay. So not every question has algebra in it. This one didn't have any algebra in it, but the next one did. So imagine question 9 and 10 are your 2 written response questions on Wednesday. Okay, so the first written response is odds and probability, a Venn diagram, another probability, quadratic graphing, polynomials unit. The second written response was explaining an exponential equation, solving an exponential equation, and then NCR. Those are your 2 written response. They're not, typically, they're not making these questions, they're not the hardest thing that we did in the units. So we did way harder stuff in the NCR unit than that. We did way harder stuff in polynomials unit than graphing a quadratic. Okay, so we did way harder stuff in those units. That's not the point of the written response. The written response is not to ask the hardest stuff. It's just to ask elements from each unit that you did. That's the point of it. Okay, yesterday we did number 8. For some reason, number 7 did not photocopy onto my slide, so we're just going to do number 7 just together. So you've got it written in front of you. It's at the very bottom of the page. So question number 7 starts at the bottom of one of the pages. Okay, so it's in your booklet. It's just not on here. So for number 7A, so the next 2 questions, so number 7 and number 6, these are the ones from last June. So I'm kind of going backwards in time here. Okay, so sorry, I take that back. 10 and 9 were from last January. 8 and 7 were from last June. Okay, and so on and so forth. And we did number 8 yesterday. So a TV game show has 16 contestants. They're from various places across Alberta as shown on the Venn diagram. So SA, and it tells you this on the question, SA stands for Southern Alberta, NA stands for Northern Alberta. Okay, and it says that there are 16 contestants on the show. So we can write 16 for the universal, and we can write, and that gave us a 6 there. Okay, so this question was kind of weird. Is it possible for somebody to be from Southern Alberta and Northern Alberta? Like, is it possible to be from both places? No. So what you had to realize here was that the overlap had to be 0, which means that 10 people are going to be from Southern Alberta. Like, that was a very strange question. Like, to have that as part A of a written response is just weird. Like, it just, like, what the Venn diagram should have looked like is that. There's no overlap. Okay? Because you can't be from Southern Alberta and Northern Alberta at the same time. So you had to assume this, which then meant that that had to be 10 because 10 and 6 is 16. Like, when I read that question, I just assumed I was thinking about it wrong because I'm like, well, it can't be that easy. But they did. They made it that straightforward, which is weird. They typically, Look, they're not trying to trick you, but that felt so easy, it felt like a trick, right? Like it's kind of the other way. So part B. So one of the games on the TV show has contestants answering a trivia quiz which contains 4 true-false questions, 3 multiple choice questions, each with 4 choices A to D. Determine the number of different possible responses that a contestant could give in the trivia quiz. Okay, so you've got 4 true-false, and you've got 3 multiple choice. So all the possible different answers, this is a NP, it's a blanks method question. The true false each have 2 possibilities. You could either answer true or you could answer false. The multiple choice each have 4 possibilities. So 4, 4, and 4. So one possible answer could be true, 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 false, A, B, C. The next one could be true, false, B, C, A. So remember, when you're doing a blanks method, the number that's going in that blank is the number of choices you have for each. So you got 2 choices for each true, false, 4 choices for each multiple choice. And you would just punch that in, timesing as you go, and get the total number of choices. Part C, another contestant was given the rational equation to solve. Provide an algebraic solution. So we've gone from set theory to permutations. Now we're into rationals. Do you notice how they're all kind of the same, right? They all have a little bit of perms, coms, probability. They all have a little bit of algebra, right? They're all kind of the same thing again and again and again. Okay, so my first piece of advice to you, if you're asked to solve a rational equation, make sure that everything is written as a fraction. Okay, what you want to do, so we did this unit through flowchart. So the first question you ask yourself is, do you have one fraction on each side? So the answer to that on this one would be no. So if the answer is yes, then all you do is cross multiply. We did one of those yesterday. If the answer is no, then we have to check for factoring. X and 1.5x, there's no factoring here. They're just monomials. You're going to find the common denominator. You're going to figure out what's missing. And then you're going to cross off the bottoms. So when you have more than one fraction, they are substantially harder questions. So there's no factoring that can be done. So the common denominator, we need one of everything that's different. So we need an x. So everything needs an x. This one has a 1, this one has a 1.5, and this one has a 1. So whatever numbers you have on the bottom, just multiply them. So 1 times 1.5 times 1 is just 1.5. So our common denominator is 1.5x. So now we go through and see what we're missing. So I have the x, I'm missing the 1.5. So I'm going to go 6 times 1.5, and I get out 9. Here, I have the 1.5, I have the x, I'm not missing anything, so the 6 stays as it is. Here, I'm missing both, because all I have here is a 1, and I need a 1.5x. So 1 times 1.5x is 1.5x. Once you get here, we get to cross off the bottoms. So 9 plus 6 is 15 equals 1.5x. Divide both sides by 1.5, and whatever that is. Now, C is clearly a harder question than A and B. Okay, so you're going to have a couple of easy sections. You're going to have a couple of harder sections. Okay, so if we look at part D, two contestants were playing a marble game where each contestant must remove one or two marbles on their turn. Whoever takes the last marble or marbles wins the game. There are currently 6 marbles left. Julie and Bob have been taking turns, and now it is Bob's turn. How many marbles should Bob remove on his turn to ensure/guarantee that he wins the game? Explain your strategy. So this question is actually one of the puzzles. It's a logical thinking. So I don't know how else to do this question except to try all the different possibilities. Okay? So remember there's 6 marbles left. Why does that come up like that? How do I get rid of that? How do I get rid of that? I don't even know what that is. Well, there we go. Okay, so there's 6 marbles left. Okay, so it's Bob's turn. Let's say Bob takes 1 marble. Okay, now there's 5 marbles left. Let's say Julie takes 1 marble. There's now 4 marbles left. Let's say Bob takes 1 marble. There's 3 marbles left. Now, if Julie's smart, what would she do? She should take 2 marbles because that would make Bob take the last marble, so Bob loses. Okay, because whoever takes the last marble or marbles loses. Oh, whoever takes the last marble wins the game. Oh, I read that wrong. Whoever takes the last marble wins the game. So hang on. Hold on. If Julie takes 1, there's 2 left, which means now Bob could take either 2 or 1, and he guarantees a win for himself. Right? So that's one option. So what, to me, that you have to do here is you have to play the different odds. Like, you have to go back and forth. So what if Bob and Julie, let's say Bob took 1 again. So it's now down to 5. Let's say Julie now took 2, which would be down to 3. Now, if Bob took 2, Julie would take 1, right? Like if Bob took 1, that would leave 2 marbles left, which means Julie would win. If Bob took 2 marbles, that would leave 1 left, which would still mean Julie wins. So that doesn't work. Okay? So taking 1 worked here, but taking 1 didn't work here. And it said, what should he do to guarantee that he wins? So maybe he has to take 2 to guarantee a win. So if Bob takes 2, that leaves 4 marbles. If Julie takes 1, that would leave 3 marbles. No, that's not going to work either, right? Because then Bob would take 1. Okay, I'm confused. Why is this not working? If he takes 2, that would leave 4. If she takes 1, that would leave 3, which means Julie wins. If she takes 2, that would leave 2, which means Bob would win. But that's not a guaranteed win. How do you do this question? There's got to be a way, right? Have you guys figured it out? But it says here, it says how many marbles should Bob remove on his turn to guarantee he wins the game? Explain your strategy. So I'm taking that as how many should he remove on his first turn? Essentially, what the game is that once there's 3 left, once there's 3 marbles left, it's that person's going to win, right? Like, because if there's 3 marbles left, if he takes 1, it leaves 2, she wins. If there's 3 marbles left, he takes 2, there's 1 left, she wins. So whoever's turn it is when there's 3 marbles left, they get to win. So maybe that's the strategy that they're wanting. That's a stupid question. On that note, that's very stupid. Okay, take your break. When you come back, we will keep going while I ponder that. Maybe just wanted to give one strategy. Because otherwise, how can you? Everything depends on what the other person does. Yes. Make it make sense. No, you can't. So it must be just a give me a scenario where Bob can guarantee himself, like where Bob would win no matter what. I bet you when they were so I've marked quite a few diplomas, and you mark about 6,000 exams over 3 days. Like it's crazy how much marking you do. I guarantee the markers who were stuck on this question hated this because they would have had to go through all the different scenarios that kids were giving because it doesn't read very well. Like either I wrote down the question wrong from my source, like from what they released to me, or or you just had to give a strategy that would make it so that Bob wins. So in that case, this would be the answer. This is a strategy that guarantees that Bob wins. Right? And again, look, it was his turn when there were 3 marbles left. So if it's your turn when there's 3 marbles left, that guarantees you the win. So maybe that's what they wanted. Who knows? Either way, that's a dreadful question. Absolutely dreadful. Okay, we did 6 yesterday. Did we not? Yes. So we did 5. And 5 in college. Okay, so we were talking at the break, and we kind of figured that probably what they meant was to just give a strategy that would guarantee Bob the win. First one, not to list out every possible strategy because that could just take forever. Or what they were actually asking for was that understanding that whoever has 3 marbles left on their turn is guaranteed the win. So something like that. Hopefully you don't get anything like that because that can be kind of confusing. But to me, in that question, I would just answer it to the best of my ability. I would just give one scenario that where Bob wins, and even if you're not sure if that's what they wanted, at least you haven't left the question blank, right? You want to make sure that you're writing something down for every part. Okay, so let's go to number 5 next. Okay. So we'll do number 5 and possibly number 3. We'll kind of see what our time is like, and we'll go from there. Okay, so number 5. So this one was from 2 years ago now. So it says the path of a basketball shot by a player is shown on the diagram below. So again, my picture is horrendous, but you can figure it out. So it says the path of a basketball shot can be modeled by a quadratic regression. Quad reg. Okay, now this question was interesting to me because, and we did talk about this in class. We did one like this. Instead of giving it to you as a table, they gave you the information as a series of points. So you've got 0, 2.22, 1, 3.53, 3.48, 5.32, 6.21, 4.87, and 8.13, 3.05. So the X is your L1, the Y is your L2. So instead of giving it to you as a table, they put those numbers on the picture instead. Okay, so I've only ever seen that one other time before this one, so they don't do it that often. Typically, they give you the data as a table, but this one they did as points. Okay, so let's review it. So second plus number 4, hit enter to clear everything out. Hit stat, pick number 1, make sure your cursor is under L1, and we're going to enter in those lists. So 0, so enter in all your X's. 1, 3.48, 6.21, 8.13. Now let's do the Y's. 2.22, 3.53, 5.32, 4.81, and 3.05. Okay. So here is my X list, here is my Y list. So I'm going to go from 0 to 10 for my X's, and I'll go 0 to 10 for my Y's as well, just to make it even. So 0 to 10 for X, 0 to 10 for Y. Go to Y equals, turn plot 1 on, Clear off everything else. Quit out. Find your equation. So stat, calc, quad reg. So that is number 5 that you're going to pick. Go to calculate. So there it is. So the question is, determine the equation and round each value to the nearest hundredth. So let me just drag and drop this screen onto there. Okay, so nearest hundredth would be negative 0.17 x squared plus 1.47x plus 2.23. Now again, they will take off half a mark for rounding if you rounded that incorrectly. Okay, so hundredth means 2 numbers after the decimal. Okay, part B, using the quadratic regression function. Okay, so when it says that, this is your twinkle, twinkle, little star. When it says use the function, that means on your calculator, you have to do the vars 5 over enter. So vars 5 over enter. Okay, so not the rounded answers, the precise answers. Hit graph. That's the path of the ball. So the question says, state the appropriate domain and range. So here's the thing. This right here, this point right here where my finger is, that is where the ball hits the hoop, right? That's where it goes into the basket. So this part of the curve right here, I actually do not need. Okay? So what that means is that in terms of the graph, it's just that. So the domain is left, right, and the right is at 8.13. So the domain is left, right. The range is bottom, top. So the bottom of this graph is right here at 2.22, right? That's the bottom. Okay, that's the lowest the graph goes. So this is at 2.22. I need to find the top. Because notice on the points, I gave you this point and this point. I did not give you the top. So we need to find the top of that curve. The top, remember, is the maximum. It's that turning point. So second trace, you're going to pick number 4. And again, either scroll to the left, scroll to the right, or do a number on the left and a number on the right. I'll go with 2 on the left and 6 on the right. So my peak is 5.42. Okay. So my top is at 5.42. So again, that was the maximum. Okay. So some of the information we could find on the picture, some of it we had to use. So this question was interesting to me for one of two things. The parts A and B were 100% graphing calculator. That usually doesn't happen on a written response. Okay. So part C. So we're still talking about basketball. Okay. At the start of the season, the odds in favor, okay, odds in favor of a student making a free throw were 12 to 43. So they make the shot, they don't make the shot. Okay. By the end of the season, they had doubled their free throw shot success rate. Okay. All right, see you later. Yeah. Determine the probability. So remember, probability is want over total. The probability that they make a successful shot at the end of the season. Okay, so the probability that they make the shot. So right now, they do make the shot. That is 12. The total is 12 plus 43. That's 55. So that's the chances of them making the shot at the start of the season. By the end of the season, it doubles. So we just have to times it by 2 because it doubled. So on your calculator, 12 over 55, and then double it. So it wanted the answer to the nearest hundredth. So nearest hundredth would be 0.44. Okay. So all the practice questions we've done, you can pretty much bank on a probability odds question. They crop up almost every diploma on one of the 2 long answer questions. Okay. They absolutely love questions that combine odds with probability. Okay. Okay, part D. A player only takes shots from point A or point B, as shown in the diagram below. The probability that a player makes a successful shot from point A is 0.455. The probability that I make a successful shot from point B is 0.375. The player shoots from side B 60% of the time. Okay? Based on this, for their next shot, determine which side the player is more likely to shoot and to have a successful shot. Okay, so you've got 2 options. So option number 1 is they shoot from A. Okay, so they go to A and they make the shot. Option number 2 is they go to B and they make the shot. So this is similar to the other question about the golfer, right, who has a good second shot. Okay, so 60% of the time they go to B side. So if they go to B side 60% of the time, or 0.6, then what percent of the time do they go to the A side? 40%. On the A side, they are successful, 0.455. And means times. On the B side, they are successful, 0.375. Now, we're not going to add these 2 probabilities. We're just going to figure out what this answer is, and we're going to figure out what that answer is. And we're going to compare the 2 numbers. So 0.4 times 0.455, so 0.18, or 18.2%. So they have an 18.2% chance of making their shot from the A side, assuming they go to the A side. If they go to the B side, and they make the shot, 22.5%. So the question was, determine from which side the player is more likely to shoot from. They're more likely to shoot from the B side. Okay, because 22.5% of their shots go in on that side. Okay. So hopefully that gives you some decent amount of practice, okay, on these written response. You hopefully got a flair for them, right, and kind of see the formula that they follow and how they're all kind of the same idea.